College Algebra, Module 8, Topic 8.1, Rational Equations and Variation. If you'll remember, a rational number is any number that can be written as a fraction. A rational equation is an equation with at least one term having a variable expression in a denominator, or at least one term having a variable expression raised to a negative integer power. So just as a rational number was a fraction, a rational equation is not just an equation with a fraction, but the fraction has to have a variable in the denominator. Some examples are x plus 2 over 2x plus 1 equals 1. 3x to the negative 2 plus 4x to the negative 1 plus 1. If you'll remember, an x to a negative power means reciprocal, so this is the same as saying 3 over x squared plus 4 over x plus 1 equals 0. And you can see different variations of the rational equations. Objective 1, solving rational equations. To solve a rational equation, multiply both sides of the equation by the least common denominator. Remember that an expression with a variable denominator or a negative exponent may be undefined for certain values of the variable. We must identify these values and exclude them from the domain. Example 1. Solve the following rational equation. Well, in this equation, the denominator, the only denominator, is 2x plus 1. So what our property says, if we multiply both sides of the equation by the least common denominator, 2x plus 1, then in the first fraction we say 2x plus 1 will divide into that once, 2x plus 1 divides into that once. So we end up with x plus 2 equals 1 times 2x plus 1, which would just be 2x plus 1. To solve that, remember we need to get the x's on one side of the equal sign and the number terms on the other. So we subtract 1 from both sides, so we get x is equal to 1. Now notice if we took 1 and plugged it back into the original problem, we would get 2 times 1 is 2, 2 plus 1 is 3. We get a denominator of 3. Notice up in the top we get, if x is equal to 1, we get 1 plus 2, which is 3. So to check that, we get 3 over 3, which is equal to 1. The next example, solve the following rational equation. X plus 3 over x equals 5 over 2. Well, in this case, the least common denominator is 2x. So what we're going to do is we're going to multiply both sides of the equation by 2x. Well, in the first side, the x's, we can divide x in top and bottom, so we would get 2 times x plus 3. On the right side, we can divide top and bottom by 2 and get 5x. Well, when we distribute this out, we get 2x plus 6 equals 5x. Now to solve this, we're going to subtract 2x from both sides, so we get 6 is equal to 3x. Divide both sides by 3, and we get x is 2. Then we always need to go back and make sure that 2 does not put a 0 in the denominator, which our only denominator was x, so therefore 2 works. Now notice if we just have a fraction equal a fraction, then it's like a proportion. And to solve a proportion, you can cross multiply. So if we did that, we would get 2 times x plus 3 on the left side, 5 times x on the right side. Notice we get exactly what we got here, so solving would give us exactly the same thing of x equals 2. But notice this only works if we have a fraction equaling a fraction. The next example, solve the equation 3x over 2x minus 1 minus 9 equals negative 6. Well, probably what we want to do here is get the fraction term on the side by itself, so we could start out by adding 9 to both sides. If we do, we get 3x over 2x minus 1 is equal to 3. And now to solve this equation, we've got a variable in the denominator. So we're going to multiply both sides by 2x minus 1. So it cancels out on the first side. So we get 3x equals 3 times 2x minus 1, which would give us 3x equals 6x minus 3. Now we want to get all of the x terms on one side, so we're going to subtract 6x from both sides, and we get negative 3x is equal to negative 3. Divide both sides by negative 3, and we get x is equal to 1. As before, to check it, take your x, plug it back in, and see if we get the original problem. 3 times 1 is 3. 2 times 1 is 2. 2 minus 1 is 1. So we get 3 minus 9, which is negative 6. So this checks. Now if we wanted to check this on our calculator, we do just like we always do to solve any equation. We go into y equals. We enter the left side of the equation as y1. Because we have a fraction, we want to put that fraction in parentheses. So that would be 3x divided by, because the denominator has more than one term, we probably need to go ahead and put that in parentheses also. So the first fraction is 3x divided by 2x minus 1. Then we have minus 9. For y2 is the other side of the equation, which would be negative 6. To graph this, either hit graph, I'm going to go ahead and go to zoom 6. So there's what our picture would look like. This graph is coming down through here. We've got an open spot right here at 1/2. And then this graph is going like this. So what we've really got, and this calculator just sort of connected the two, but really this is not there. So there's only one solution. So to find that, we would go second trace, which is calculate. Number 5, first curve, second curve, enter. Okay, on our calculator, let's go back and look at something real quick. For the fraction 3x over 2x minus 1, this value is undefined if the denominator is equal to 0, which means 2x minus 1 is 0, which means 2x would be equal to 1, or x would be 1/2. So if x is 1/2, there is no value. Well, if you'll notice over here on the graph, at 1/2, there is no graph. Here's 1/2 right here. The left side of the graph is coming in like this. The right side is coming in like that. There is no value of the graph on that 1/2 line. Well, on our graph, it really looks like it is because the graph connects those. If we come over here and go into mode, you see like the 5th one down where it says connected. So if we go over to dot for a minute, and press enter, and then we graph it, see that just gives us the points. So this graph goes down forever this way. This graph comes up this way. It never hits that 1/2. So when we try to find what is equal to 1/2, we're going to do second trace, which is calculate. Number 5 is the intersection. Now the first curve, you notice how this first curve is on the left side of the opening? It's never going to cross the x-axis, and we know that because if we go second trace, which is calculate, number 5, enter, 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 notice we get an error that says there is no sign change. That means the left side of the graph does not ever hit the 1/2. Well, now if we go back and do the other side, second trace, number 5, now the first curve, what we want to do is we want to arrow over so that we're on the right hand side of the graph. Press enter. The second curve is the -6, press enter. Now when we hit the graph, we get that it intersects at x is 1. Okay, let's do another example. Solve the rational equation x divided by x minus 2 plus 1 divided by x plus 2 equals 8 divided by x squared minus 4. This one is not one fraction equaling one fraction, so we can't cross multiply. So we're going to do multiply both sides by the least common denominator. Well, first we need to find that. Well, this factor is just x minus 2. This factor is x plus 2. Now x squared minus 4 will factor as x minus 2x plus 2. So your least common denominator is the expression that contains an x minus 2, an x plus 2. Notice this expression, x minus 2x plus 2, is already over here. So this is our LCD. So now what we're going to do is multiply both sides of the equation by this LCD. So we've got x minus 2x plus 2 times the left side, x minus 2x plus 2 times the right side. Well, I'm going to go ahead and write this out. Okay, so this expression shows every term being multiplied by the LCD. Now what happens is we go through and divide top and bottom by like factors. So in the first factor we can divide x minus 2 into top and bottom, and we get x times x plus 2. In the second term we can divide top and bottom by x plus 2, and we get 1 times x minus 2. And in the third term, we can divide top and bottom by x minus 2 and x plus 2, and we just get 8. So this gives us an equation with no fractions. So simplifying this, we get x squared plus 2x plus 1x minus 2 equals 8, x squared plus 3x minus 2 equals 8. Now because this is quadratic, we're going to set it equal to 0, so we're going to subtract 8 from both sides, and we get x squared plus 3x minus 10 equals 0. Well, to solve a quadratic, we can factor it. So we'll do x and x. Last two have to multiply to give us negative 10, so we'll try 2 and 5, knowing one's a positive, one's a negative. So when we do, we get 5x for the outer two, 2x for the inner two. We're trying to get to a positive 3x, so we're going to make the 5 positive, 2 negative. When we set each factor equal to 0, x minus 2 equals 0, x plus 5 is equal to 0. So we get x is equal to 2, and x is equal to negative 5. Well, notice if we took 2 and plugged it back into the original equation, we would get 2 over 2 minus 2. Well, notice that would give us 2 over 0, which is undefined. So that means that 2 cannot be a solution because it makes the denominator 0. So we say that 2 is an extraneous solution. Okay, extraneous, think extra. It appears to be a solution, but it's really not. So our only solution would be x is equal to negative 5. And sometimes you'll see students write this as 2, negative 5, and then they'll mark out the 2. But technically the only solution is negative 5. Okay, let's do another one. For this one, the LCD of 1x and x squared is x squared. So we're going to multiply both sides of the equation by x squared. So when we distribute that x squared, so we get x squared times 1 minus x squared times 13 over x plus x squared times 36 over x squared equals x squared times 0. Well, first term just gives us x squared. Second term, we can divide top and bottom by x, which would leave us x times 13, which is 13x. Third term, the x squareds will cancel, so we get 36. Then the right side is just 0. Same thing. Now we could solve this quadratic formula by our calculator. I'm just going to go ahead and factor it. That would be x minus 9, x minus 4. Set each factor equal to 0, so we get x is 4 and x is 9. Now notice 4 and 9 both work. Neither of them would give a 0 in the denominator, so our solutions would be 4 and 9. Now if we wanted to look at this one on our calculator, we would have 1 minus, then in parentheses, 13 divided by x, close that parenthesis, plus, new fraction in parentheses, 36 divided by x squared. And then the other side would be equal to 0. Now when we graph that, again, 0 makes the denominator 0, so the graph is undefined at 0, so the domain is all real numbers except 0. So if you'll notice on the graph, at 0, there is no value. The left side is going up, getting closer and closer to 0. The right side starts pretty close to 0 and comes down, but the graph never hits 0. Now for this problem, we are trying to find where the graph intersects with y equals 0, which is the x-axis. If you look here, it drops below the x-axis and then comes back up. So if we do second trace, number 5, enter, notice on the first enter, it normally starts at 0, but there is no value at 0, so what we need to do is arrow over so that now the first curve is on y1, press enter. The second curve is on y2, press enter. We don't want to guess, and it crosses it at 4. Then when we do it again, second trace, number 5, enter, enter. This time we're going to move the cursor to the right, press enter, and we get the solution of 9. Now had we not done this one pencil paper method, we probably would not have known that there were two different solutions. So that's why it's a good idea to solve it on your paper and then use your calculator to check it. Objective 2, variation, inverse variation. Well, if you'll remember a few topics ago, we did direct variation. Direct variation was where we set it up y equals k times x for some k. Well, for inverse variation, we're going to do it a little different. Let x and y denote two quantities. Then y is inversely proportional to x, or y varies inversely as x, if there exists a non-zero number k such that y is equal to k over x. The number k is called the constant of proportionality or the constant of variation. Let's do an example. If y varies inversely as x, so we're going to start out, if y varies inversely as x, that means y is equal to k over x for some k. Then they give us a little part of the problem. So we're going to take the second part of the sentence. If y is 2 when x is 3, and we're going to plug it in our formula. We're going to substitute y is 2, and we're going to substitute x is 3. Now we need to find k. Well, since we've got k divided by 3, to solve for k, we're going to multiply both sides by 3. So we get k is equal to 6. So that is our constant of variation. The second part says we'll find the equation of variation. Well, we said a second ago that y is equal to k over x, but now we know that k is 6, so our equation becomes y equals 6 over x. Then the third part says, then find y if x is negative 2. Well, we've got an equation, so we're just going to plug in x is negative 2, so we would get y equals 6 divided by negative 2, so y would be equal to negative 3. Okay, let's do another one. This time it's all in one. If t varies inversely as s, okay, t varies inversely as s, so t equals k over s. The variables go in order. If they mention t first, t goes first. Varies inversely means k over. The variable that comes second goes in the bottom. So the first thing we're going to do is find k. So we're going to take what they give us. T is 5 when s is 6. And we're going to plug it in. 5 equals k over 6. Well, to solve for k, we're going to multiply both sides by 6. So we get K is equal to 30. Second thing we're going to do is find the equation. Our equation was T equals K over S, but we know K is 30, so our equation becomes T equals 30 over S. And then the third part says find T when S is 15. So we're going to take S is 15 and plug it into our equation. T equals 30 divided by 15, so T is equal to 2. Okay, another example. Let Z be inversely proportional to the third power of T. Z is inversely proportional to the third power of T. So our equation would be Z equals K over the third power of T would be T to the third power. So again, the first thing we're going to do is use what they give us to find K. So we get 0.08 equals K over 5 to the third, which means 0.08 equals K over 125. Now to solve for K, we're going to multiply both sides by 125, which gives us 10. So K is equal to 10. So our new equation becomes Z is equal to 10 over T to the third. And then the third piece says find Z when T is 2. So we're going to plug it in. We're looking for Z equals 10 over 2 to the third, which would be 10 over 8, which would simplify to 5/4. So for this problem, Z would be 5 over 4. Okay, now let's do some applications involving the inverse variation. The weight of an object varies inversely as the second power of the distance from the center of the earth. Let's say it again. The weight of an object, we'll call that W, varies inversely as the second power as the distance from the center to the earth. So that would be distance squared. So our equation becomes W equals K over distance squared. So the first thing we're going to do is find K. The radius of the earth is approximately 4,000 miles. So that means the distance from the center of the earth, that's the radius. So we know that's going to be 4,000. And then what they say is if a person weighs 160 pounds on the earth's surface, so that means the weight is 160 equals K over the distance from the center of the earth is 4,000 miles. But the formula says squared. So we would get 160 equals K divided by 4,000 times 4,000 would be a 16 million. So to solve for K, we're going to multiply both sides by 16 million. So K is equal to 2,560,000,000. So our new formula would be W equals this really big number divided by the distance from the earth squared. And this is another little tricky part. Our formula says that the distance from the center of the earth to the surface of the earth is 4,000, and then they're saying that it's 8,000 miles above the surface. So we've got another 8,000. So for this problem, the distance that we're looking for is 12,000 squared. So we're going to take the 2,560,000,000 divided by 12,000 squared, which gives us the weight of that person would be 17.78 pounds. Okay, you are now ready to do the homework for Module 8, Topic 8.1 in my math lab. If you have any questions, let us know.